Hello future professionals, welcome to day 22 of our top 100 coding question analysis. Today we are challenged with a question to find if a given number is an Armstrong number or not. Now that we have our problem statement defined, let's have a hands-on experience of solving the problem. First, let's get to know what is an Armstrong number. The definition is that a positive n-digit number is called an Armstrong number of the order n if the sum of the individual digits of the number raised to the power of the order of the number is equal to the number itself. Don't worry if you find it confusing. Let's look at the list of Armstrong numbers, then we shall try 3 practical examples to get more clarity. The list of Armstrong numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 153, 370, 371, 407, 1634 and so on. We see all the single digit number are Armstrong numbers because their order is 1, that is, the number of digits in the number is 1. So, the sum of the individual digits raised to the power of its order will always be equal to the number. Let me prove that the single digit number is Armstrong number. Let us take the number as 1. Its order is 1 because there is only one digit. Next, we calculate the sum of the individual digits raised to the power of their order. We have only one digit, that is 1, and its order is 1. So, when we calculate the sum, we get 1, which is equal to the number itself. So, it is an Armstrong number. Next, let's try for the number 9. The order is 1 because we have only one digit. Next, we calculate the sum. Since we have only one digit, that is 9, and raised to the power of their order, we get 9. That is nothing but the number itself. So, this is an Armstrong number. Next, let's try for a 3-digit number, that is 153. The order is 3 because the number of digits is 3. Now, let's calculate the sum of individual digits raised to the power of its order, that is 1 power 3 plus 5 power 3 plus 3 power 3, that is equal to 1 plus 125 plus 27, that gives us 153. That is nothing but the number itself. So, this is an Armstrong number. Right? A bonus example would be 370. The order of the number is 3 because the number of digits is 3. Let's calculate the sum of individual digits raised to the power of their order, that is 3 power 3 plus 7 power 3 plus 0 power 3. We get the result as 27 plus 343 plus 0, that is nothing but 370. That is the number itself. So, this is an Armstrong number. Now, it is your turn to check if the number 1634 is Armstrong number or not. Let me give you a hint. The order of the number 1634 is 4. If you find 1634 to be an Armstrong number, comment down as 1364 is an Armstrong number. Let's now reread the definition and let's check whether the definition makes sense now. A positive n-digit number is an Armstrong number of the order n if the sum of the individual digits of the number is raised to the power of the order is equal to the number itself. I hope now the definition makes sense. Now that we have got the hands-on experience of solving the problem, let's look at the logic. The logic is that first we need to get the number from the user. Second step would be to find the order of the number. Third step would be to find the sum of individual digits raised to the power of their order. Next, check if the sum is equal to the number. If yes, if the sum and the number is equal, then we print the number is Armstrong number. If no, then we print the number is not the Armstrong number. The last step would be to terminate the program. Great, we have understood the logic, so let's put it into practice by coding our program. Let's start the code by defining a function to get the user's input. I name the function getUserInput. Here, we get the number from the user and store it in the number variable. Now let's return the number variable. Next, we define a function to validate the input, that is, check whether the input is a number or not. If it is a number, we return true, else false. Next, we define the check Armstrong number function with the number as parameter to check whether the number is Armstrong number or not. Here, we initialize two variables, that is, n to the length of the number, that is, the number of digits, and the sum to 0. Next, we use a for loop to select the individual digits of the number to calculate the sum of the individual digits raised to the power of the order. Next, we check if the sum is equal to the number. If it is equal, then we print the given number is an Armstrong number. Else, we print the number is not an Armstrong number. Now that we have defined all our required functions, it's time we call them. Let me call the getUserInput function and store the return value in the number variable. Next, we check if the input is a valid number. If it is a valid number, we call the Armstrong number function by passing the number as arguments. Else, we print enter a valid number. Now let's check for any errors or warning signals. There is no error or warning signal, so let's run the program. Let me check for 1. It says the number 1 is an Armstrong number. Let us check for 9. We get the number 9 is an Armstrong number. Let's check for 153. The program gives me the number 153 is an Armstrong number. Let's check for 120. It says the number 120 is not an Armstrong number. Thus, we have successfully completed our program. I hope you would have got the best out of this video. I recommend you subscribing our channel to get more such interesting videos. I also recommend you to like and share our videos if you find it interesting and supportive.